Okay, hello students. Today I would like to introduce to you to lesson 5.1, Introduction to to Trigonometry. And the lesson is about 5.1. This is the beginning of a short video just to understand what is the definition of, what is the meaning of radian major. So what does this mean? So the definition begins with is, let me quickly read for you. 1 radian is measure of an angle subtended at the arc. Now what is the meaning of subtended? Is like cut. So piece of the circle where the angle is made. So let me draw that. At the center by an arc of a circle having length, so I'm putting that important information, this length has to be equal to the radius of the circle. Like let's see, we have a circle here, and in this case I'm going to use a unit circle. It could be 1 inch, it could be 1 inch or 1 foot or 1 meter. So I'm just using one for the purpose of understanding how do we get 1 radian. Okay, so let me begin with that. This is the center, and then I join. So there is a radius. I said there is a radius of, let's see, this starts with, I can call this as P and O. So this is the radius 1 unit. So 1 unit. So it could be anything. Now what I do next is I try to get an angle. I try to mark an arc here. Or of course there will be radius right here also, right? So this is the radius also. I can move this radius over here exactly the same distance, you see. And this radius which is right here, I can wrap around the arc. So this radius which is also 1 unit, you wrap around the arc. So this will move up this way. Okay, and it will wrap, and it won't wrap exactly the same distance, right? Somewhere here maybe. So I'm gonna wrap this maybe somewhere here. So this gets wrapped around and moves exactly. It wraps this piece of the part of the circle. So if this is 1 unit, so you see this becomes 1 unit also. That's the length, right? So the length of the arc. So this is also arc length. So when you have, and then I can join this piece from here to here. So from here to this, you join. You can see the definition says an angle, that is whichever that is here, is angle. What is 1? So this by definition is called 1 radian. You see that? So 1 radian by definition is, it is the angle at the center. It's a central angle also. So when you talk about measure of an angle subtended at the center, so this is also central angle, and whose measure, and suddenly we think of some kind of opening. See, this angle is formed like this with 2 radii. This is 1 unit. This also is 1 unit. You can clearly see the red color. The length, arc length is equal to the radius. So this is like the radius r, which is the radius. So that's the definition of arc length. Now, how do we use this definition to figure out what is that 1 radian in terms of degree measure? Or we say, what is this 1 radian in? So what I'm going to do next is to show is, so it's like so 1 radian is the length equals, right? So I can draw another circle here, and let me draw another circle like this. Okay. And let's say this is 1. So this is 1 radian, right? So this radian will be, until here will be 1 radian, okay, because this is 1, right? So this is one of the piece. I cannot go and go ahead and do another one from here and until here maybe. So this also is like 1, see? So we want to know how many of this radii can fit. So this also is 1 radian length. I can go beyond this and say, okay, let's go one more with arc length whose length equals to the radius. So you have another 1 radian. So we want to know around, let's say, how many of those radii can fit the whole circle. Right? Okay. Thank you. I'll take care of it. Just give me 30 minutes. Okay? So we want to know in this example, in this case, how many radius can I fit around the whole circle? Okay, so it's difficult to exactly figure out what is 1, 1, 1, and we want to know how many of them, right? So we want to know all around the circle. If it is all around the circle, it's like, it is called circumference. We need to know how much is the length of the whole circle. So what I do is I'm going to show model to you here, and okay. So here I have a ruler. Of course, I'm just using a model right here. So let's say this is a circle. I'm just using this as a circle with radius 1, and this is the starting point. Let's see, this is the point here. Of course, it is this way, but because of the way I have to explain, I'm trying to show the same thing, but I put it like this. So I'll start with, as if this point P is here, this is the point P. So this point is P here, this point, okay? So I'm going to start here, and I want to see what is the length of the circumference. So this means this radius has, remember this is 1, right? Of course, all of you, we do know what is the circumference, 2 pi r. So we do know what the meaning circumference is 2 pi r, and our radius is 1, right? So basically the length of the arc is, if you see this, it starts here, and I'm going to turn this. Okay, so start from here, and then I go on turning. See, I can turn this, it moves. So I want to know the whole length, even though we know that, but still I would like to show with the help of this model. You can see right here, back again. So I'm going to fix that point here. Okay, so that means we have a circumference. So from here to here, this was the original point P, this was P, and let's see, this is the Q, and I join this. Okay, now this I use because the model that I showed had different radius, but I call it like, use it at 1 unit. Now this is from here to here. We want to know how much is this distance, right? And this distance is 2 pi, which is 2 pi times 1 is 2 pi. So the whole round, so if this is 1 radian, the whole around the circle. So if I want to know how much is this, if this is 1 radian, how much is this whole thing, like this? So that's like the length of the circle, the whole circle. So from P to Q, this is 6.28. And how it is? Because 2 times 3.14 is 6.28. What it means is, how many of this, can you see this part? So 1, here I showed 1, 2, 3, maybe 4, another 1 radian, and maybe 5, another 1 radian, this is 1 radian, and then another 1, I'll make it a little longer maybe here, and this goes somewhere here, this is another 1 radian, this is the length of the arc. So you have one altogether 1, 2, 3, 4, 5, 6 radians. So this until here is 6. So it is 6, and this is like doesn't become 1, but it is 0.28. That means it is just a fraction, 1/3, almost like a third of a 1. So this is one radius, another radius, another radius, another radius, another radius. So we have 6 of them, and then a small piece which is almost 2/100th of a 20/100th of a 1. So this is how it is. And then I'm going to finish this video quickly. Also, now that we know that what is the whole around, 1 radian is there, but all around the radian is 2 pi. So this is the important information. And then again you can see that if you go around, we know it is 360, right? So the whole around is also from here to here, this angle, the whole angle, let's see, start from here, start from here, go all across. This is 360 degrees. So what that means is, I can use this as, this is radian, this is radian, so I can write another line like this to say, hey, the whole around is 360 degrees. This is 0 degrees. So we want to know what is the relation between radians and degrees. So if you look at this, is the whole around is 2 pi radians, right? And also we know it is 360 degrees because the whole around is 360 because you have 180 and 180. That's what we've been always using all the time. But suddenly right now we have in radians. So we want to know 360 degrees. So this whole PQ is, I put this mark as, let me make it a little longer to say, let's see. So let's use this as, I use 2 lines to make quick observation that this is 0 degrees and this is 0 radians. Okay, so let's just start. This is 360, all around is 360 degrees. But here we saw that it is 2 pi, right? Of course, 2 pi is 6.28. So I don't want to think too much of this. We already know that means 6 radius will fit the whole around and also a 0.28 here. If you see here, so the 2 pi is 360. So I can divide this into half and say, hey, half of 360 is 180 and half of 2 pi. So if I do 2 pi divided by 2 is just below this will be pi. So what did we learn here is that 180 degrees, so this is 180 degrees is pi radians. And in the symbol form, you can write 180 degrees. We know degrees is written as 180 raised to the power small 0. And this is, because we are talking about circle, going around a circle, we put a small c in radians. So 180 degrees is pi. We can also divide this into more half like this. So that means half of 180 is 90 degrees. So half of pi will be pi by 4. And likewise, we can build up. So this is, pi by 2 here. So this is 0. So this is pi by 2. So I'm just trying to build. Then also I want to break this into 3 parts like this. Like, so what I'm doing is, the reason is I want, the main is the 30 and 60. So if I want to divide this 90 by 3, and you get 30 degrees, right? So this becomes 30 degrees. That means I have to divide this pi by 2. So a third of pi by 2. So what is the meaning of that? A third of pi by 2 is pi by 6. So this is pi by 6, right? Then this is 30 and this is 60. So if this is pi by 6, this is 30, this is going to be 60. So it is twice pi by 6. So this will be 2 pi by 6, which can be written as 2 pi by 3. So 60 degrees is 2 pi by 3. So, sorry, pi by 3. I made a mistake here. This goes and you get pi by 3. So what I want you to do is, hey, that's what we learned. What is 30 degrees is pi by 6, 60 degrees is pi by 3, 90 is pi by 2, 180 degrees is pi by. And I can also think of this here. What is that? Between 180 to 360 is 270 degrees. You can think of like this. This is 90 degrees. This is 180 degrees. This is 270. This part, I'm sorry, is 270. This is 0. So you go like this. This is 270. That's what I was trying to say. So 270 is you can see there are 190, another 90, another 90. So 3 90s. That means you have 90, 90, 90. That means this pi by 2 is 3 times. So this red color pi by 2, I can use and say, hey, that's 3 pi by 2. So these are the important information that we should know for this short video I made, just to understand what is the definition of 1 radian means, and then we know how many radians or how many radii fit in the unit circle, and you can see it is 6.28. So we say, okay, that is 6.28, which is 2 pi. So we have been using 2 pi and not 6.2. 6.28 is just to understand that you can how many radius wrap around the whole circle, and you can see there are 6 of them, and almost like a 1/3. 0.28 is. So I'm just using 0.28 is like a 1/3 approximately, like 1/3 of a radius. So these are the main information at the tip of the tongue. You're supposed to remember this, hey, 30 is pi by 6, pi by 3, and so on. So we can still continue like this and write down 3 more like this. See, you can, that part we will have separately, because 30, 60, 90, 120, 150, and you can all like this. We can go on filling this 240. This is 240, 270, 300, 330. So these are the main numbers, and you can just go on like this. This is pi by 6, this is 2 pi by 6, this is 3 pi by 6, and you can go on with 5 pi by 6. So this becomes 5 pi by 6, and 6 pi by 6, but this is 2 pi by 3, because even though this is 6 pi by 6, but 6 pi by, so pi by 6, 2 pi by 6, 3 pi by 6, this is 4 pi by 6, so this is 5 pi by 6, and this 4 pi by 6, it can reduce 4, even though it is 4 pi by 6, so here we'll write 2 pi by 3. So the goal of this part is this video is only to understand what is 1 radian and how many radii fit in a circle. It doesn't matter, you can have more radii, more than 1, it will be the same thing. How many radius fit. So the 2 pi is the main thing, where 2 pi is 366. So let's end this with, what did we learn here is that 360 degrees is equals 2 pi radians, and if you divide, the main thing will be half of it. We have seen 180 degrees is pi radians, and now we can write in the unit rate. Notice that unit rate, if I want to know, so this can be written in 2 ways, because very soon we are going to do how to convert degrees to radians. So this can be written as 1 degree, so dividing both sides. So if you divide both sides here by 180 this side, and if you divide this side, see, this 180 crosses out, and you get 1 degree is pi over 180. So that's one formula, and this answer is in radians. Okay, this part. And the second part is, if I want to write down what is 1 radian is, so 1 radian is, let me write this back again. So the beginning you have 180 degrees is pi, but this time you're dividing by pi both the sides. So dividing by pi both sides, this goes away, you get 1 here. So 1 radian is, so 1 radian, RAD shortcut, is 180 by pi degrees. and we can easily figure out any of the, suppose I give you, let's see, if I have what is, let's see, 140 degrees, convert from degrees to radians. So how do we do? So you just multiply the conversion rate. So 1 degree is this. So if I want to convert this 1 degree, I have to write 140 degrees, 40 times, you have to multiply this pi over 180, so pi over 180, and this whole thing will be in radians, right? So converting from degrees to radians, we multiply. That's an easy way to remember. If it is degrees, you can't have a pi up, okay? I mean, you can't have a number. If it is degree, you have the pi degree, then the 180 has to be down. So up, down. And if it is like changing from radian to degrees, it's just 180 over pi. So here it is pi times. And you can see, if I can reduce this, 10 divides both numerator and the denominator. So we can write it as 14 pi over 180. And you can still reduce this to 2 goes 7 times pi and 2 divides 2. So that's the answer in radians. And also you can also, they can give you, hey, what is pi by, let's say I'm gonna use, what is pi by 4, which I forgot to give. What is this? So this is given, let's say, in radians, and you want to know what is this in degrees. So how many degrees here is this answer? So how do we do this? We use the second one. 1 radian is, unit rate is given 1 radian. So if they ask you pi by 4, then we change this pi by 4. This time we multiply. Pi is up here. So your pi has to go, the conversion rate is 180 divided by pi. And this whole thing is in degrees. So you're just multiplying 180 over pi using that conversion rate. Now, this pi goes away and you get 180 divided by 4 degrees, and that answer is going to be 45 degrees. Okay, so that's all I wanted to show, that hey, I'm concluding this video, even though I did forget about putting this on that line there where what is 45, and you can see that 45. And this is the chart to remember at the tip of the tongue. So how do you remember this? There's a trick here. Remember 30 and 60, they always complement. I would remember that, hey, 60, what is 60? Remember 60 and 3. If it is 6, then that is 3. If it is 30 degrees, it is 6. So this is how you can remember without breaking your head. Okay, 60 is, so if it is 6 is up, 3 is down. If it is 3, then it is 6 down. Pi is always there. But what about 45? You see, 45 starts with 4. So if it is 4, you take the 4 down. So simple. 90 degrees, once you know 180 is pi, so 90 is half, right? So you just divide by 2. So that you can remember that. 270 is 3 times 90s. So once you know 90 is pi by 2. So pi by 2, pi by 2, pi by 2 is 3 by 2. Okay, so next class we will see, I will be showing, after knowing this, we will see the length of the arc, the area of the sector, and also we will see what is angular velocity and also linear velocity. So that will be my next video. Hope this helped you guys. Thank you.